Hello and welcome. This is a video that I've added on to the Unit 3 for Physics. It's called a moment sample question, and the reason why I've added it is because sometimes you get a question on moments that's not quite as straightforward as what I've got on the picture here, and this is what we've been dealing with in our previous video on moments. If, by the way, you are not clear at all about moments or a little bit shaky, you can go back and have a look at the video that I've done on moments, and that will explain it in much more detail. But for now, we're going to move on and look at a slightly more confusing, or what might be a slightly more confusing problem to have to solve. So firstly, let's go with something simple that we have been working with. Here I've got an unknown force, and I want to work out what it is based on the data given. So this is a balanced beam, and we know for a balanced beam the anti-clockwise moment is equal to the clockwise moment. That's just saying that the clockwise turning force and the anti-clockwise turning force are the same. So if we were to work it out, the clockwise side we have 200 times 2, and on the anti-clockwise side, which is going in this direction, we have a force times the distance of 1, and if we were to work it out, we end up with a force of 400 newtons. And as I say, if this is a bit unclear and you're not sure, you can go back and look at the moments video, but if you're quite happy with this, we can move on to the next example that I want to deal with. So here it is. There was a question similar to this on the specimen paper, and the confusing thing for this diagram is that we don't seem to have anything on this side of the diagram. There doesn't seem to be anything balancing out the forces that we have on the left hand side. But if you think about it carefully, we have our anti-clockwise force, which is created by this weight. We have our pivot, but we don't seem to have our clockwise moment. But if you look over here, we've got another force which is acting in this direction, and that's opposing our anti-clockwise moment. So this in fact is our clockwise moment. It's actually acting in the clockwise direction. So then, or this is the clockwise force, should I say, and it's creating the clockwise moment, the clockwise turning force. And if we now know that, that's going to make this problem slightly more easy to do. Now I'm going to do this question with color coding so you can see which units I'm working with, but in the exam you won't have the color code, so you might have to come back to this slide just to see what's going on. But what I've done over here is I've got the anti-clockwise moment all related to the blue stuff and the clockwise related to red. So we can work out our anti-clockwise moment. So that's quite simply a case of our force, which is 0.04 newtons, times our distance of 4 centimeters, and on the other side, on the clockwise side, we have a force which we don't know, times a distance of 16 centimeters. Now the first thing you might be thinking is, hold on a minute, these units are in centimeters, and we know the force for the moment is the Newton meter. So your first instinct might be to convert this into 0.16 for meters, and this into 0.04 meters, and then do your calculation. You are more than welcome to do that. You'll end up with exactly the same answer, but in actual fact for this question, because we're working out the force, we don't need to add in the extra layer of converting these, dividing both of these by 100, because it's not actually required. And if you think, or if you're not clear about that, you can actually try it with both methods and you'll see you'll end up getting the same answer. So here we go, 0.04 times 4 is 0.16. Over this side we have force times 16. If we rearrange the formula, we have 0.16 divided by 16 equals the force, and that answer equals 0.01 newtons. So our answer that goes in our space over here is 0.01 newtons, and if you look, it's of the magnitude of the scale of our force that we have over here already, so that makes us think that this is in the right ballpark. In actual fact, this is the correct answer for this question. But as I say, you might be concerned about this conversion of units, but if you go ahead and try it with these figures instead of the figures I've used, you'll find you'll get exactly the same answer as 0.01 Newton. Okay, so a slightly trickier example that you might come across. So a quick example of something that you might see that's not as straightforward as our balanced beam, and how you might approach it. Remember, what you've got to do is look for the clockwise and the anti-clockwise moment, and that should make it clearer. You may have to deal with centimeters in a question, but remember, if we're working out the force, you don't necessarily need to convert these into meters. It doesn't matter if you do, and if you feel more comfortable converting it, it's not a problem at all, because you end up getting the same answer. Okay, so that's it. Thank you for watching, and I'll see you again soon.